Welcome to another episode of learning. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem that has appeared in the CSIR National Eligibility Test held on December 15, 2019. The question is from the section Algebra, in particular from ring theory. And the question is related to the maximal ideals and prime ideals. This question is placed in part C, which is a multiple select question. There can be more than one answer, and the question carries 4.75 marks. The question ID is 187-980-1823. Right. The given question is, let C in brackets 0, 1, the closed interval 0, 1, be the ring of all real valued continuous functions on the closed interval 0 to 1. So C01 stands for a ring. Who are the elements? The elements are all real valued continuous functions defined on this unit closed interval. Let A be the set of all those continuous real valued functions satisfying f of 1 by 4 is equal to f of 3 by 4 is equal to 0. So those continuous real valued functions which vanish at 1 by 4 and 3 by 4 are in A. Then which of the following statements are true? We are given four options. Option 1, A is an ideal in C01 but not a prime ideal in C01. Option 2, A is a prime ideal in C01. And option 3, A is a maximal ideal in C01. Option 4, A is a prime ideal in C01 but not a maximal ideal in C01. The question is basically about the prime ideal and maximal ideals. Whether this A is a prime ideal or a maximal ideal, then go on answering the options. Let's now discuss the solution of the problem in detail. We have C01. That is a ring. It is the ring of all real valued continuous functions defined on the closed unit interval. It is known it is a commutative ring with unity, correct? And given A is the set of all those f belongs to C01 that vanish at 1 by 4 and 3 by 4. And claim A is a proper ideal in C01. First of all, let us see whether it is a proper subset of C01. Yes, clearly A is a proper subset of C01. How? You take a function f of x is equal to x, the identity function. It is clearly a continuous function, real valued function, and it belongs to C01. But f of x is equal to x will give you f of 1 by 4 is 1 by 4 not equal to 0. That means f of x is equal to x does not belong to A but belongs to C01. So there exists some elements in C01 which are not in A. Therefore, A is a proper subset of C01. Now recall the ideal test. When a non-empty subset A of a ring R is an ideal of R, the test gives if 1. A minus B belongs to A for all AB belongs to A. And condition 2. RA belongs to A and AR belongs to A for all A belongs to A. And R belongs to R. Right. So, now we use the test. Condition 1. Fg belongs to A. That means Fg belongs to C01 and vanish. F of 1 by 4 is equal to F by 3 by 4 is equal to 0. G of 1 by 4 is equal to G of 3 by 4 is equal to 0. Now, this implies F minus G belongs to C01. Why? Because F is continuous, G is continuous. The difference of two continuous functions is again a continuous function, therefore it belongs to C01. And F minus G at 1 by 4 is F at 1 by 4 minus G at 1 by 4. That is 0 minus 0 is 0. Similarly, F minus G at 3 by 4 is also 0. Therefore, thus F minus G belongs to A for all Fg belongs to A. Right. And now let R and F, R belongs to C01 and F belongs to A, be any two elements. Now, test now RF. This is the second condition you are testing. RF at 1 by 4 is R is also a function at 1 by 4. F at 1 by 4 is equal to R at 1 by 4. It may be anything, but F of 1 by 4 is 0. So multiplication gives you 0. So RF of 1 by 4 is 0. Similarly, RF at 3 by 4 is also 0. So this implies RF belongs to A for all R belongs to C01 and F belongs to A. Further, FR also belongs to A for all R belongs to C01 and F belongs to A. Why? What's the reason? You are not testing, but you are saying simply it belongs to A. It is because your C01 is a commutative ring. When it is commutative, RF is equal to FR. Therefore, FR also belongs to A. Agreed. So, both the conditions are satisfied. Thus, A is a proper ideal in C01. Agreed. Right. We continue in the next slide. We have seen A is a proper ideal of C01. Now we take option 1. A is an ideal in C01. Yeah, it is. But not a prime ideal. We don't know. We will see. A is a prime ideal in C01. We don't know. We will see. Option 4. A is a prime ideal. We don't know. If it is a prime ideal, is it a maximal ideal? That's the question. Agreed. First, we have C01 is a commutative ring with unity, that you recall, and A is a proper ideal of C01. Now recall the definition of the prime ideal. An ideal, a proper ideal of the ring R is said to be a prime ideal whenever AB belongs to A, implies A belongs to A or B belongs to A. Agreed. This is the definition. So, let Fx is equal to x minus 1 by 4. Gx is equal to x minus 3 by 4. Note down, this Fx doesn't belong to A because f of 3 by 4 is not 0. So, also g of x, g of 1 by 4 is not 0. Therefore, both of them are not elements of A. But they are continuous functions. Because they are polynomials, they are continuous functions. Therefore, their product is also a continuous function because the product of any two continuous functions is again a continuous function. Now, further, Fg on f at 1 by 4 is f at 1 by 4 into g into 1 by 4 is equal to f at 1 by 4 is 0 and g at 1 by 4 is not 0 but it is multiplication gives you 0. Now fg at 3 by 4 will give you f at 3 by 4 multiplied by g at 3 by 4. But f at 3 by 4 is not 0, but g at 3 by 4 is 0. Therefore, it's equal to 0. So, it tells you fg belongs to A. Now, fg belongs to A, but is f belongs to A? We have seen f doesn't belong to A. fg belongs to A. Is g belongs to A? We have seen g doesn't belong to A. So, fg belongs to A, but neither f nor g belongs to A. So, it violates the definition of the prime ideal. Now, fg belongs to A, but f doesn't belong to A because f of 3 by 4 is 3 by 4 minus 1 by 4 not equal to 0. G doesn't belong to A since f of 1 by 4 is equal to 1 by 4 minus 3 by 4 not equal to 0. So, thus, A is not a prime ideal in C01. So, option 1 is true. A is an ideal but not a prime ideal. Yes, option 1 is true. A is a prime ideal of C01. No. Option 2 is not true. A is a prime ideal in C01 but not maximal ideal in C01. It is not a prime ideal. Option 4 is also not true. So, we are left with option 3. We will discuss that in the next slide. Yes. Option 3 says A is a maximal ideal in C01. Is it? Is it a maximal ideal? Now, we will argue C01, first of all, note down, it is a commutative ring with unity. That's a must. And A is not a prime ideal in C0, which we have seen already. A is not a prime ideal. So now, recall the definition of the maximal ideal. An ideal M of R is a maximal ideal if it is not possible to squeeze an ideal between M and the full ring R properly. We cannot put it properly in between M and the full ring R. Right? That is why it is called maximal ideal. Right? Assume that A is a maximal ideal in C01. But now you recall a result. In a commutative ring, every maximal ideal is a proper ideal. Then you will get A is a proper ideal. But the fact is A is not a prime ideal. It's not a prime ideal. Every maximal ideal in a commutative ring with unity is a prime ideal. Is a prime ideal. That is the result. But it is not a prime ideal. Right? So therefore, our assumption is wrong. Therefore, A is not a maximal ideal in C01. Recall this result. Every maximal ideal in a commutative ring R with unity is a prime ideal. That is why I said a commutative ring R, commutative ring with unity, that C01 is very important. So assume, if you assume this one, so by this result, A is a prime ideal in C01. But we have seen A is not a prime ideal. Since why is a prime ideal? Because you are using this result. Right. This is a contradiction to the fact that A is not a prime ideal in C01. Therefore, our assumption is wrong. Therefore, A is not a maximal ideal in C01. So, option 3 is not true. Right. So, summarizing all the options, we see the answer is option 1. That is the detailed discussion of the solution of this problem. As I have been telling you, and whenever you see a problem, what are the concepts that you have come across? You have come across, two concepts. One is a prime ideal and the other is a maximal ideal. Now, what is a prime ideal, what is a maximal ideal, you have to note down that. Therefore, you should know the definitions of that one. So, when a maximal ideal becomes a prime ideal, that is, when it is a commutative with unity, every maximal ideal in it is a prime ideal. So, such results. So, now you have come to know what is to be noted down. The concepts of maximal ideal and prime ideal and the results thereon. You go on studying them, be comfortable, write down in the form of a notes, and that will be helpful. That's the way of preparing notes for this examination. Right. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We hope to meet you once again in another episode of learning. Keep learning. I wish you all the best. Thank you.